Hello, everyone, and welcome to the Concord Virtual IA Renewal Series, again, hosted by Concord Battery, and I will be your presenter this today. This will be talking about the EWIS, or Electrical Wiring Interconnect Systems. Welcome. Concord Battery and Dassault Falcon, which I work for. So my name is Jody Kerton. I'm a system specialist, or an ATA specialist, as some call it. And my domains are electrical, lighting, starting, and fire systems of aircraft. Well, in this particular case, Falcon aircraft. But for today's presentation and discussion, we'll be talking about wiring on all aircraft. So just a little bit about myself. I've been with Falcon Jet for a little over 10 years. I've been in the aviation industry for about 25 to 30 years. And my role at Dassault Falcon Jet is, as I said before, a system specialist. So we are considered level 2. We are a level in which level 1 are field reps, guys and gals that are working in the service centers that are working directly with the customers and their aircraft. And the command center, or help desk, as some OEMs have it. So they will contact us if they need more information, maybe something a little bit deeper in the troubleshooting area, maybe something where we might have to go to the design office, in this case in France. So we work with investigations and failures of components and areas in the aircraft a little bit deeper than the ones that are on feet on the ground, talking to customers. I also have been involved in a local association called Westchester Aircraft Maintenance Association. It's out of the New York area. And I've been president for about 9.5 years. I'm just stepping down, so there'll be some new folks running the organization. Our mission for that organization is basically education. A lot of key speakers speak on behalf of their products and services. We offer training and advocacy, of course, for maintenance technicians. So for today's agenda, we're going to be talking about, as I mentioned, electrical wiring interconnect systems. A lot of folks never heard of the term EWIS before, EWIS. We've had a lot of IA renewals in the past, a lot of training through different areas, different schools and things like that, and not many of them have heard of EWIS or know what EWIS is. And it's a new term within the last 10, 20 years. And what we can talk about today basically is the definition of EWIS, why we have EWIS, what we had before EWIS, so what kind of aircraft designs incorporated wiring or designs and wiring, the type certification of OEM aircraft, Dassault, Gulfstream, Bombardier, Boeing, etc. We're going to introduce EWIS. We're going to do some accident recaps of how EWIS started, the road to EWIS from non-EWIS, and some of the working groups and committees that are involved in the safety of aircraft with EWIS in mind. We've got some new regulations from the FAA after EWIS has been developed. We have got the FAA Aircraft Circular 25-1207. We've got aircraft design, implementation, wiring protection and security, and of course documentation now that we have this in place. That moves us to maintaining aircraft under EWIS. So we've got different kinds of inspection criteria, servicing of the aircraft with EWIS in mind, the ICA continuous airworthiness, and protection and security of all of the wiring and related areas. How do we maintain EWIS? We maintain EWIS by educating technicians, service centers, having awareness. And then I'm going to show some sample photos of some of the interesting wiring mishaps and wiring things that have been lost along the way, and the conclusion. So again, what is EWIS? Electrical wiring interconnect systems. Well, the original definition of EWIS did not include the interconnection of components. It only served to make people aware of the components itself. So the term originated, of course, in the aviation industry of electrical interconnect systems, or EIS, where we've added the interconnect of the wiring to the components. So if you're familiar with, in the FAA world, if you're familiar with advisory circulars, we've got FAR 25-1701, which defines the term EWIS as wiring device, any wire or wiring device combination of these, including termination devices installed in any area of the aircraft for the purpose of transmitting electrical energy, including data and signals, between two or more intended termination points. The term wire means bare or insulated wire used for the purpose of electrical energy transmission, grounding, or the bonding of the wire. This includes electrical cables, coax cables, ribbon cables, power feeders, and data buses as well. Well, now that we have EWIS today, what did we have before EWIS? Well, as you know, and if you're familiar with some of the older aircraft, we had some aviation accidents, but before that, in the 1930s and 40s, aircraft had no electrical systems. Yes, they had an engine and they had magnetos, which were self-sustaining electrical for the spark plugs, but there was no running of any cables or any wiring in the airplanes. And many times they had to use flashlights and things like that. Actually, automobiles had more wiring than airplanes at that time. And since there were fewer accidents caused by electrical systems or wiring, there was no thought to placing wiring or safely placing wiring in any of the aircraft within the aircraft itself. It was more of a fit and forget mindset when you install things. The idea was to make the airplane fly. Well, of course, it takes bad things to happen for good things to develop. And I'm going to bring three cases, three accidents that had EWIS in mind. If you go back 1996, July 17th of 1996, we had a TWA Flight 800 in Long Island, New York, off of a place called East Moriches, off the island, south shore of Long Island to the Atlantic Ocean. January 9th of 1998, we had United Airlines 767-300 flight from Zurich to Washington, D.C. And in that same year, September 1998, Swiss Air Flight 111, which was an MD-11, crashed into the Atlantic Ocean. Let's take the first horrible case right now. July 17, 1996, TWA Flight 800-747. It took off from JFK. A mid-air explosion happened on climb out. The NTSB investigated 4 years before using a 2000 report that they thought that there was, well, there were several possibilities. One was a missile or something had accidentally shot down the aircraft, but later on, while putting the airplane together, the only thing they could come up with was a spark, possibly in the fuel tank that was not carrying fuel. From that, there was the idea of fuel tank inerting, or putting an inert gas in the fuel tank to replace the oxygen that might have been in there. If there was any bad wiring within the fuel tank and a spark caused it, oxygen, of course, would have caused an explosion in there. So in my last bullet, fuel tank inerting, in 2001, the FAA issued requirements for adding to commercial jets fuel tank inerting systems. These systems replace potentially explosive fumes in fuel tanks with nitrogen-enriched air. Today, a lot of airplanes will have nitrogen-generating systems replacing the oxygen in some of the tanks. Again, some of the wiring between fuel pumps or fuel gauges can have power and ground running through the tanks, which is normal as long as everything is insulated properly. That's not so bad, but not knowing what this was, fuel tank inerting is now a normal system in fuel tanking. 1998, a flight from Zurich to Washington, D.C. was forced to execute an emergency landing at London's Heathrow. Again, it's an awareness because a food chiller unit improperly installed in the electronic and equipment bay. There was a chafed corner of the food chiller. There was heavy wiring, and the wiring chafed against a metal object or metal frame part of it. It scraped the wire, and therefore it was almost a full bonding of power and ground, which caused the fire. They were actually able to land the airplane, but in the ensuing chaos of landing the evacuation, a right-wing escape slide failed to deploy, and several minor injuries occurred in that one. Again, we're going back to wiring and the awareness of wiring and its surrounding frame areas. And the last recap today is Swiss Air Flight 111, September 1998, of the McDonnell Douglas MD-11. In this case, the MD-11 took off from New York again late at night for Geneva. Just under an hour later, the pilot and co-pilot detected smoke in the cockpit, and the aircraft crashed into the Atlantic Ocean, killing 229 people. They did find arcing in the overhead, which powered a cabin system. The 4.5-year investigation by the Transportation Safety Board concluded that a fuse connected to the in-flight entertainment system had blown above the cockpit, and flammable installation material used in the aircraft structure allowed a fire to spread beyond the control of the crew. So it wasn't so much that it was the electrical, the actual shorting, but the material that was used around the area was flammable and caught on fire that way. So from the accidents, more and more investigations happen, a lot of discussions on what exactly happened and what would be the way to mitigate some of these accidents and things from happening. Well, EWIS is born by a development of the Aging Transportation Systems Rulemaking Advisory Committee, or ATSRAC. It was established. It was chartered to gather industry leaders to examine the current state of the aging aircraft systems. The committee included several key organizations and large businesses, ATA, NASA, Northwest Airlines, and a lot of OEM, commercial, and private entities came together as part of the committee. The road to EWIS understanding and compliance would begin after the investigation happened. And of course, new FAA regulations were released around the 2006, 2007, 2008, governing the aspects of EWIS on aircraft, both in service and in production. So let's examine and talk about the road to EWIS. So we talked about the various working groups. Under the ATSRAC, Aging Transportation Systems Committee, the purpose was to develop areas where we could discuss small transport aircraft. We'll talk about the committee members, who they are, what kind of inspections we would be looking at to increase safety. Under the aircraft manufacturers, how do we report some of these anomalies that we find during the inspection, so that we talk about the reports of the working group. What are the impacts of regulatory changes? How does that change the inspections? Do inspections take longer now that we have to look in more areas? How do we document what we found? How do we train the technicians that are looking at this, and how do we make them aware? And of course, maintaining the aircraft on a continuous basis as aircraft aging continues. So the purpose of this, in 1999, we proposed to revise the FARs and guidance material as may be appropriate to ensure the non-structural systems in transport airplanes are designed, maintained, and modified in a manner that ensures their continuing operational safety throughout the service life of the airplane. From the NTSB recommendations, It is to ensure that all transport category airplanes are included in its review of aging transport aircraft systems. Well, we've got a lot of committee members that are on board with this, and some of them are regulatory, FAA, JAA, CAA, Transport Canada, and we've got many industry associations, including MBAA, SAE, U.S. Department of Transportation, Department of Transportation, Gamma, IATA, NASA, NADA, NEMA, and AECMA, CMA, ALPA, and ATA. Product manufacturers in this particular one is Thales Avionics, and we've got aircraft manufacturer OEMs, Airbus, Boeing, Bombardier, Dassault. Airlines include AirTran, British Airways, Delta Airlines, Lufthansa, Northwest Airlines, and some of the service centers, starting with PEMCO World Air Services. So under the committee members, we've got working group airliner inspection results. So throughout the development of the committees and the discussions, we've had people go out into the field and look at inspections during the time that they're required. And we found lots and lots of defects and anomalies. Maybe some of them did not require immediate action, but we could see that if they were left unchecked, that they could cause a problem later on. Again, hundreds requiring design changes or enhanced maintenance inspections, maybe increased clearances between some wires and some framing areas. Aging studies included that there were some inadequate design, so that means there were inadequate spacing between wiring and the surrounding areas. So if that was designed in production, then those production changes needed to happen on the OEM level. Some of the production modified even in service. Some wirings that were aged, of course, were going to be deteriorated. Some were found with corrosion. Corrosion may have happened, from spillage. Some just from condensation, or not ever seeing that area before. Improper wiring installed and repairs, and of course, contamination of wire bundles with metal shavings. If any service bulletins or after in-service work was done, of course, you're going to have contamination of some of the things if they're not cleaned. Dust and fluids, of course, which would provide fuel for the fire and some of the other materials. For instance, unsecured bundles on or near flight control services. In this picture, you can see a cable, flight control cable, which is very close to a large electrical bundle. The bundle happens to be on the upper area of it, soon to sag and soon to chafe against the stainless steel cable. The stainless steel cable will win when chafing against wiring. So for sure, if there's power and ground in that area, there will be some circuit breakers popping, or even worse. Bundles, wire coax feeders allowed to rest on structure. Again, this is a lack of supporting the large and heavy cables. Some of these cables are 0 and 1 or 2 gauge cables, some feeding very high current devices also. In this case, too tight of a bend on the radius. So it looks like a repair was done, maybe a butt splice, and the butt splice should not be done in a turn at all. It should be done with at least several inches on either end of straight wire area. A design office, if they were asked to give a recommendation on the repair, would not have recommended such a repair as this. So if you work for a company and there's a design office involved, you be sure to ask for the recommendation, repair recommendation or repair scheme with all the details of what you're doing to the design office. And then they should be able to give you the proper design authority and approval for that particular repair. Here's a case where somebody created some new wiring, some new harnesses, and inappropriately or incorrectly marked the wire with a wire marker, which is normal for the coating on the wire. The wire marker was placed in it too hot. It was in there for too long, and of course burnt the insulation of the wire in this case. So let's look at the various OEM comments and observations and statistics that were recorded during some of these inspections. We found no aging issue specific to wire insulation and conductor. Inadequate clearances in 29% of the discrepancies, there were inadequate clearance between the structure and any wire or any racks that are surrounding it. 68% of significant items were due to inadequate clearance. Again, bad clamp conditions, sizing, and spacing. Of the clamping, 43% of the discrepancies found from bad clamp conditions. And the routing. Almost all discrepancies are caused by improper wire routing, repair practices, lack of training. Now, the production wiring, it typically is going to be implemented based on the actual original wiring design of the airplane. But if the airplane's been in service for many, many years, again, any modifications done outside of that, improvements, retrofitting, may not comply exactly with the way the original wiring was. In fact, there probably was no original wiring showing any of the retrofit type of improvements. So the design of the improvements or the retrofit is done usually at the service center level. They're not always taking into consideration every area of the aircraft during the design of this. So it requires the technician who's installing it to kind of be aware of where you're going to be mounting all the wires, clamping the wires, and ensuring that it's not going to be a safety hazard down the road. All discrepancies can be detected and rectified during scheduled maintenance if it's found and the technician is aware of it. So what did we find during the evaluation? Let's take a look. Again, not properly secured, use of tie wraps instead of using cable clamps, chafe potential. Here you can see wires that are kind of tied together, but through the years that tie wrap may fall, it may break, and you don't know where the wires are going to be dropping. Pinching of harnesses, wires that are set behind certain areas that have hardware that could be sharp. In this case, there was they shoved a harness behind this nut and bolt screw here. This has a large area where it could chafe against the wires. So potentially this is not a safe way to install this cable, and longevity is not very long on this one. A large high current feeder was pinched between two, looks like solenoids in this area here. And this could have been routed a different way, but again, looks like that wasn't the case in this work. These are high current feeders that have to be separated from some of the other areas, especially metal areas where they could chafe and then short out. So there are many times when retrofits and modifications require the removal of equipment. The removal of equipment may remove the rack, the equipment itself, the device itself, but sometimes the wiring remains. In this case, they found a connector that would normally have been connected to the back of a rack. The wiring and the connector itself remained, but the rack was gone. So there's an exposed, possibly an exposed power still going to this connector. It should have been depowered, of course, but who knows? In this case, this was just hanging loose. And we have two cable types resting loosely on each other unsecured. This is below the floor, of course, something you don't see on a normal walk around, but in this case, this cable, when it kind of looks like a TCAS or some kind of retrofitted cable in there, just kind of laying down on top of another cable. And very close by is a frame above it, which is a floor, which, of course, as you know, you'll be walking on it and it'll be flexing down. So again, this is not a very safe and secure harness. This one has many anomalies in this particular inspection area. We've got chafing on one side. We've got unsecured bundles. The use of a bulkhead connector shell on a mobile connector there, a wrong type of connector, and it's sitting there with other cables next to it, which the nut on the connector could be eventually chafing into some of the others. And we've got a connector back shell clamp exposed to other harnesses. Again, this is an area where it's probably not looked at normally. It's probably below floor. The last person in here, I'm sure, didn't do all of these at the same time, but if you can imagine, several years, one person will be looking at it and another one for another inspection, and they're not looking at everything. They may look at everything they did, but they don't look at everything that was done. So in the case of continuing maintenance, this would not be very good. It's imperative that if you're going to go in there and do your own work, you need to look around to see what others have done as well. Pinched wires under cable clamps. We see this all the time. Added wiring, and too lazy to open up the cable clamp or put a larger one to accept the additional wiring. This one was just placed behind the connector. Eventually, yes, it's plastic, so maybe nothing would happen, but suppose it was metal, something could happen. But again, if you're going to add wiring, use the original cable clamps in the area as long as they're big enough. And if it's not, then change the cable clamp to a larger one. Here we go again. Looks like coax on the outside, no clamping, and resting on a clamp underneath. This one lost its rubber part of the inside of the cable, so now you've got metal to the high current cable. This one is a generation cable or starter generator. So again, large current items have to be really paid attention to when it comes to mounting and routing. Coax cables resting on chassis are no protection and no clamping, and this one will probably chafe and cut into the cable eventually, and they'll find themselves with, if it's an audio cable, probably static, probably not working at all. But again, just the looseness of the cable could interfere with something else. Pinched feeders. This one, it was under the floor again. These feeders, again, no protection between the edge of this metal cover and the feeders itself. This happens a lot. There's a lot of heavy feeders, and if you can see here, a lot of heavy feeders in the area where there's even smaller wires behind it. And the smaller wires behind it actually look very, very rat's nesty, if you will. But protection between the large and heavy current cables and those cables is imperative as well. Here you can see very clearly that this particular connector was not aligned. It's actually off kilter a little bit. This would never click into position when fully home. And it could possibly have bent pins in this particular position also. It doesn't take much to bend a small pin if you've got a 50-pin connector. Here's one. This one was actually a production, brand new airplane. The nuts for these particular wires were not even cinched down. It's not that they were loose, they weren't even home enough. They probably worked for a little bit, but in this case, they wouldn't have worked for very long. But I'm very surprised to see this production airplane with this condition. This one was on a helicopter. There was some display issues that were coming and going, red X's and things like that. And when they pulled the connector off, one of them, pins weren't even clicked into place in this particular connector. They just happened to be pulled out. So one pulled out, and then the technician tried wiggling on the other ones, and they all pulled out. So what are the reasons for these discrepancies that we've been seeing? Again, we mentioned previous wiring repair not to specifications, misrouting of modification wiring, the lack of non-use of industry standard guidelines. In this case, you're supposed to have your AC 4313 available, and the OEM standard practice manuals, chapter 20, which is now incorporated in many of the aircraft maintenance manual areas. Any service bulletins or any new kind of projects always have, in the beginning of the generals, always have the chapter 20 requirements and safety requirements for beginning a project, like a service bulletin or an AD. Clamping or structural contact with the airframe, instructions for continued airworthiness, the ICA issues, under 14 CFR Part 25, Section H 25.5 A1. Protect, clean as you go philosophy was not used. And lack of awareness and lack of training. There are most of the considerations that we found. So since 2007, our advisory circular for the FAA side came up with 25.1701-1, which is a certification of electrical wiring interconnect systems by the transport category airplanes. And the 1701 talks about aircraft design and incorporating the EWIS philosophy within production aircraft. So that means the design of the wiring within the aircraft must be maintained throughout the certification of the aircraft, as long as it's going to be airworthy. So the maintenance and the inspections have to follow that as well. System separation requirements. That means if you've got AC, you've got AC wiring, you've got DC wiring, you've got grounds, you've got heavy current wiring, light current wiring, coax, audio, data bus. Standard wiring practices documentation 25-6 and AC 12094. Now, this isn't all of the AC advisory circulars. These are just some of them, but this is how the FAA has continued with the EWIS philosophy. Aircraft electrical wiring and connect training programs under 120-94. So we've got improved maintenance. So again, since 2007, this is when it came out, the FAA published the Enhanced Airworthiness Program for Airplane Systems and Fuel Tank Safety Final Rule. The intent of the rule is to help ensure the continued safety of commercial airplanes by improving the design, installation, and maintenance of electrical wiring systems. I won't read the whole thing, but basically that's the beginning of the advisory circular. Okay, ACJ requirements or recommendations to enhance the maintenance of the aircraft EWIS through adoption of the aviation industry of the following. Enhanced zonal analysis procedure. How do we determine what areas we want to look at that we don't really look at normally? So we call them zone areas or zonal inspections. The guidance for general visual inspections, or the GVI, and protection and cautions once we arrive at the area where we've gone to protect and look at. In the prevention, protection and cautions recommendations, structural repairs, STC modifications, and field approval, we found that extreme care should be exercised to protect the wiring from mechanical damage by tools or other equipment. Drilling blindly. Now we know we can drill blindly and drill into something, obviously into a piece of wire or some kind of heavy current wire or some other piece of equipment. Drilling blindly into aircraft structures should be avoided. Know what's on the other side of what you're drilling. Precautions should be taken to prevent contamination of any kind from entering the wire bundle. Is it an area under the center console in the cockpit? Is it an area where coffee or soda or water can be spilled? That's an area to look at. Bathrooms, spillage in the bathrooms, galley, areas under the galley. Did water overflow one time and spill on the floor and nobody said anything about it? All wiring and electrical components in the debris field should be covered or removed to prevent contamination or damage. Protection and caution recommendations. Okay, how do we gain access to where we want to? The OEM always prescribes what inspections and what areas based on the recommendations and requirements of the OEM. If wiring must be displaced or removed for work area access, it should be adequately released from its clamping or other restraining provisions. That's the only way you're going to see what's on the other side. And this is to allow movement without damage and return after the work is completed. Component removal installation relating to attached wiring. Use protective caps in all connectors, especially ones that you've removed from a rack that you no longer use, or remove the wiring completely. Use protective caps on all connectors, plugs, or receptacles to prevent contamination or damage of the contacts. Protection and caution recommendations. You should avoid pressure washing areas where the area could not drain or cannot be exposed to an air dry. There are times when you just don't use pressure washing because even normal rain would not get in there unless it was pushed in there by a pressure washer. So avoid pressure washing at all costs. Pressure washing. Care should be exercised when spraying water or cleaning fluids. The application of corrosion prevention compounds. There's a whole corrosion prevention system or program for all OEMs, and this is due to the aging and corrosion of possible areas, external and internal as well, and the proper compound and solutions that are used for this. Care should be taken to prevent containing CPC from coming in contact with wire and components. Servicing, modifying, or repairing waste, water, oil, or hydraulic systems. To minimize the attraction and adhesion of foreign material, care should be exercised to avoid any fluid from reaching electric components and wiring. I say this because some of these compounds can be sticky, that can hold a residue, and of course anything that's sticky or even wet can attract dust, dirt, and metal filings as well. So you don't want them in between wiring harnesses. After a while, the metal obviously will try to eat through the insulation and cause shorting between things like the center conductor and the shielding on the outside, which sometimes the shielding is the ground side, and of course the center conductor is positive, and there's where you'll have your shorting. Protection and cautions recommendations. Inclement weather. Keep doors, panels closed as much as possible. To prevent ingress of snow, slush, or excessive moisture. A lot of airplanes are maintained out on the ramp. A lot of airplanes are maintained with no hangar. If you don't finish a job, don't leave a panel open. Obviously water, snow, and anything can get in there. The airplane isn't airtight to begin with. All you need is a panel open, and water and rain can get inside there and pool somewhere, and you may not be able to see it later on. So obviously, the best place is working in the hangar, but if you can't, close everything up if you're outside. Cleaning of electrical wiring, interconnect systems. Extreme care should be exercised. This is what we're talking about. If you're going to be drilling or doing any kind of work, look at the environment in which you're working and make sure you either cover it while you're working or make sure you wash everything down and clean everything between wires when you're done. We have something called a electrical load analysis. All airplanes have it. They will change throughout the life of the airplane every time you add or take away a system in the airplane. If you're going to upgrade an airplane, the load changes, obviously, the weight and balance changes, but the load will change also. The load will change if you remove a system as well. So updating and making sure you record all of your changes in the electrical load analysis when the work is done has to stay with the airplane so that the next person who's installing a system can refer to the last electrical load analysis, and that should be held close to the airplane itself or the previous or the current owner. More documentation. This is a sample from a 7X. We spoke about the precautions that are built in now to the accomplishment instructions of every task or service bulletin. In this case, the recommended master breakdown index shows this, same index for all original aircraft manufacturers. In my case, the Dassault documentation, we've created an AMM Chapter 20, which brings in all of the safety requirements in the AMM and also, again, in the accomplishment instructions of each of the service bulletin projects. This covers all the EWIS requirements as well, replacing MRI 5150 section, and will be referred to in the maintenance and procedures and service bulletins, as I mentioned. Well, we need to be trained on looking at EWIS from now on. We may not have been able to do that. We didn't have recommendations. We looked only at the task at hand if we were doing something, but it takes your eyeballs to move around the environment in the area so that we can look at the whole area. So the objective of the training program is to ensure that proper procedures, methods, techniques, and practices are used when performing maintenance, inspection, alteration, repair, and cleaning of all electrical wiring interconnect systems in the aircraft in which you're working. So this has become very important because in order to maintain proper EWIS system within the airplane, we've developed a program to ensure that those who are working on the airplane are trained properly. So the use of the FAA AC 120-94 I mentioned before, that came out in 11/20/07, is the guidance for developing an enhanced electrical wiring interconnect system training program. And all facilities, including OEMs, production facilities, facilities that are in-service facilities and afterwards, and flight departments, all should be aware of this training program. The training program should be applicable to the following: air carriers, air operators, and repair stations. It may also be used by type certificate holders and supplemental type certificate holders as well. The recommendations in this AC can be applied to any aircraft training program. Qualified staff performing the EWIS maintenance, that means most of the technicians or all the technicians that are actually working on the airplanes. Qualified staff performing maintenance inspections on the EWIS. Qualified staff performing electrical avionic engineering work. Qualified staff performing general maintenance inspection, not involving wire maintenance. So the awareness is there, whether you're working on the wires or you're not. The general awareness should be there as well for everyone. Qualified staff performing other engineering or planning work. Other service staff with duties in proximity to EWIS, aircraft cleaners, fuelers, etc. And of course, your flight deck, flight crew, and your cabin crew as well. So the requirement requires initial training and recurrent or refresher training. It should be conducted for each designated work group in accordance with a qualified plan. And your recurrent training should be conducted in a period not to exceed 2 years. It could consist of a review of the previously covered material, plus any new material or revisions to publications that are coming out. Well, the human element basically is going to be the ability to be aware of EWIS, the need for awareness and enhancement. Actions must be taken to convince all people involved with aviation management, aircraft maintenance and operations that extended inspection time and improved working procedures are fundamental in achieving an improvement in continuous airworthiness. So I've come up with something called SUM: self-awareness, understanding, and mindfulness. We have to go in as technicians with this in mind. Self-awareness. Do I feel both mentally and physically able to perform the job properly at hand today? This brings in something called human factors. Do I have the proper tools for the job? Should I ask someone else to do it since I have never done it before? Understanding. Do I have a full understanding of what the job entails? Do I know how to use the terminal lug crimper in this case, or am I too afraid of asking someone? Do I know what it's supposed to look like when I'm done? Training. Mindfulness. I think I know what to do, but I'm not sure. I'll try it anyway. It doesn't seem to get tight. I can sort of pull it out a little bit. Seems a little loose. Oh well, no one will see it, and it is buried behind the instrument panel. This scenario happens all the time, and this picture shows the second repair. The first one failed. The repair consisted of a Go team going out, finding burnt wires, installing new terminal lugs, and could not use the crimper properly. The wire pulled out by a mere pull on the wire itself. So again, a couple of areas: not recognizing what a proper crimp should be, not being trained on the crimper that's used. And you can see in this case, the crimper wasn't crimped down all the way because it did not have the crimp dimples that would normally be there on the terminal insulator itself. So in this case, a third repair had to be done properly, as this was the second repair after the original failure. What are some of the examples of self-awareness, understanding, and mindfulness? The use of manufacturing procedures for wiring, and all OEMs have their own manuals that show how to properly repair a wire bundle, wire feed-throughs, installation of fuses in line, installation of diodes. This particular picture shows a diode that was broken because the tightening of the tie wraps on either end of the diode resulted in the stretching and the pulling and breaking eventually the wire going to the diode itself. You are supposed to put a service loop in the diode, and then you can cinch it down with the tie wrap. If you leave no service loop, the cinching down of the tie wrap on either end will eventually pull from cold and heat, pull the wire out of the diode and have a failure. And most of these diodes are inline fuses, or some of these areas are hidden and deep within certain wiring bundles, usually in areas that you don't really access on an everyday basis, so you don't really see them or know exactly where they are. Staggered splices. Does everyone know how to install splices so they don't end up being 10 inches round on the bundle? Splices and bundles should be staggered so as to minimize any increase in the size of the bundle that would eventually prevent bundle from fitting into its designated space, cause congestion adversely affecting maintenance, and of course cause stress on the wires itself. So refer to your procedure for the wiring for each OEM that you're working on. And if you are not sure about that, then call your local design office for the OEM or your local field rep, which would can make you contact the designated wiring area and officials that would tell you what the repair scheme would be. For this particular one, we had a production airplane that over time, a large heavy currented wire or cable eventually sagged and came in contact with a metal ducting area on the side of the aircraft. Now, cables can sag because of gravity, so that requires mindfulness of adding cable clamps that would prevent certain wires from sagging. In this case, SAG was not thought of at the time, but EWIS, SAG is now part of the EWIS program in making sure that the cables are secured properly so that we can eliminate sag. The fix to this one was putting the heavy wire below the ducting, and the ducting is now composite rather than metal. An interior was installed and a headliner was repaired. In this case, there were several feeders that are attached to a metal clamp on the ceiling of this particular airplane. The metal clamp is mounted such that the feeders, if they are pushed too hard up into the ceiling, the feeders would be cut like a knife with this metal clamp. This would not be the case if they had removed about a 1/4 inch layer of foam that was on the original headliner. What they did was they put 2 layers. The original layer did not come off, so a second layer of foam went on the headliner. When the interior people mounted the headliner to the aircraft, it was about a 1/4 of an inch thicker than it should have been, which then pushed the heavy current cables more into this metal bracket, such that the metal bracket eventually shorted all 5 cables together. So this was not seen. This was in the overhead, hidden behind the completed overhead panel in the cabin. And it was only after smoke in the cabin happened that we determined that excess pressure that was put on the cables cut into the clamping. It didn't happen overnight, but again, through vibration, it eventually did happen. So the training, we talked about the training should be, the awareness of the training should be extended to anybody who's working on the airplane, not just the technicians, but interior folks as well that understand some of these simple concepts of pressure in the areas that should not be there. So this concludes the EWIS, and I don't want to see some of these, the way you ground some of these things. So any questions? I'm going to conclude this presentation. My name again is Jody Kerton. I work for Dassault Falcon Jet. This is my office number, mobile number, and you can email me at this particular email, jody.kerton@dassaultfalconjet.com. I thank you very much for listening. It's been great. This is my second recording, and I hope you have a great rest of the day. Thank you so much.